Okay, so magnification calculations. So the first thing to remember is the equation. And to remember the equation, we can think I am. And so that is just a nice triangle of I am. Okay. And when we put that into a triangle like that, that tells us, therefore, that magnification is equal to image over actual. Okay, now the magnification doesn't exactly have units, you just have a times. The image size and the actual size will have units, and when you're doing these calculations, it's absolutely critical that those units are the same. The image size is what you measure on that piece of paper, and then the actual size is whatever the genuine real size of the thing that you have magnified is. You can rearrange this equation to then be able to find out any of the three things if you have two of them. Now, in terms of the units, we work in the metric system with the thousands. So if we started with a meter, then we'd go to the millimeters, then we'd go to the micrometers, and then we would go to the nanometers, and it's 1,000 each time. You will notice that centimeters don't appear in this because centimeters don't work. Okay, now 1 meter is 1,000 millimeters. So to go from meters to millimeters, then you multiply by 1,000. To go from millimeters to meters, you divide by 1,000. Okay, now when we're working with these sorts of calculations, we're not really dealing with meters, but the same principle applies. So if you've measured something in millimeters, say it's 8 millimeters, to find it in micrometers, you would times it by 1,000, so it becomes 8,000 micrometers. If you measured 800 micrometers and you wanted to turn it to millimeters, then you would divide it by 1,000 and it would become 0.8 millimeters. So they're all the same. And likewise, to go from micrometers to nanometers, you times by 1,000. To go from nanometers to micrometers, you divide by 1,000. Okay? Now, there are some rules with magnification calculations. Rule number 1 is never, ever, ever, ever use centimeters. The reason for that is that centimeters don't fit into this nice thousands thing. And so you can get yourself confused because you just think, oh, I've got to do everything by thousands. And then you forget that with centimeters, you don't. And then rule number 2 is that when you're calculating magnification, the units need to be the same. So that means that sometimes you have to convert some units before you start doing your calculations. Okay, so there are there are different ways that questions can be asked. You can find magnification questions in the multiple choice section. So this would be an example. This isn't really a magnification calculation, but it's about magnification. So the images are microscopic views of two similar cells. Okay, so you can see you've got two similar cells here, and you can then it's asking what is the reason for the difference between the two micrographs. Just FYI, it's always sensible to read what it says underneath the images here, this reference. Now this one isn't particularly useful, but quite often they actually give you quite a lot of information. So when we look at this top image, it's really fuzzy compared to this lower image, which tells us this lower image has a greater resolution. Okay, that's the difference here. The magnification is largely the same. So we're looking for something about resolution here, and you can see that B is the lower image has the greater resolution. So that might be some type of question that you would be asked about magnification in the multiple choice, looking around the definitions of magnification and the definition of resolution. So if you aren't sure on those, then it would be worth going and looking those up. Also knowing how light and electron microscopy varies with regards to magnification and resolution. I want to keep on the calculations though for today. Then the next type of question might be something like this. So in the multiple choice section, you're not actually allowed a calculator. So you are allowed a ruler though. So it's always going to be a bit of an approximation here. So we know that magnification equals image over actual size. Okay, so if you were to measure this, obviously I've cropped it and changed it, but I'd reckon it's probably about in the region of, I don't know, 1.5 centimeters maybe, so say 15 millimeters. But the actual size is in micrometers, isn't it? So we've got 5 micrometers as my actual. So if my image is 15 millimeters, then my actual is going to be 15,000. Okay, which gives me a magnification of 3,000. Okay, so there's my answer. Now, even if we'd measured that at, I don't know, 10,000, so that then my answer was 2,000, that's still the closest answer. So with those ones, there's an element of approximation and just choosing the most appropriate answer. Now, in your short answer questions, you get 2 types of magnification calculation. So the first type is like this, where you're being asked to calculate the magnification of the image, okay? So again, we would write out the equation. It is always sensible to write out the equation. Quite often you get a mark for doing that. So magnification is the image size over the actual size. Okay, now the bit of the image that we're looking at here is this part here, the scale bar. So we know here that the actual size is 15 micrometers. So we would then measure this scale bar, okay, and you'd measure it from end to end. Again, obviously I've cropped the image and I'm working on a computer here, so I'm not entirely sure what it was, but for the sake of simple maths, I'm again going to say that it was 15 millimeters. Okay, so then if it's 15 millimeters, that doesn't work because the units aren't the same. I've got millimeters up here and micrometers down there. So I need to convert my millimeters to micrometers. So I'm going to make that 15,000. And so then my answer would be times 1,000. Okay, now you will notice here it says showing your working, which is exactly what I have done. So please, if we go back to our rules, I'm going to add a third rule. Okay, and rule number 3 is show your workings. Now I know when I used to do maths, my maths teacher used to say to me all the time, show your workings. I'd be like, what's the point? It's really easy. But the point is that actually, if you looked at the mark scheme for this question, you can see it's out of 2 marks. You get 1 mark for that. You get 1 mark for the correct answer. You get 1 mark for this, for showing your workings. Okay, so please make sure you're doing that. Okay, so that's your probably most straightforward type of question. Then the other type of question is a little bit more complicated because it's using the scale bar. Now, interestingly, the way that this question is phrased, so we've got an electron micrograph of 2 adjacent pancreatic cells. Okay, and what it's now asking you is, using the scale bar, determine the diameter of the nucleus on the left, giving the units. So basically it's asking you what is the actual length of line XY. And then part B is deduce the magnification of the image. Now I actually think you have to do these questions the other way round. And I'll explain why. Because the information that you have is around here, it's around the scale bar. So you can do exactly what we just did in the previous question to deduce the magnification. And then once you've got the magnification, you can use that to calculate the length of line XY. So what I'm going to do is I'm going to do it that way round. So to deduce the magnification of the image, magnification is image over actual. Okay, so we know that our actual size here is 400 nanometers. Okay, so our image size has got to be in nanometers. Now I'm going to say that it was 10 millimeters. Okay, so 10 millimeters would be 10,000 micrometers, and then we're going to have to multiply that by 1,000 again to turn it into nanometers, and then we're going to divide that by 400. Okay, so in terms of the maths, we can get rid of some zeros there. Okay, and then it's 2 carry 2, so then it's 2,500. Okay, so it's times 2,500. For these types of questions, you would be allowed to have a calculator. Okay, so I now know that my magnification is 2,500. So now I'm going to go back to question A. Determine the diameter of the nucleus on the left, giving the units. So the information that we have here, so if we go back to our triangle of I am, okay, what we want is the actual size. So actual equals image over magnification. Okay, now here, key point is your image units needs to be appropriate for the scale of the picture. Now we know that the scale bar has been given in nanometers, so it would make sense for your image to be in nanometers. So we're going to imagine that we measured this 1 centimeter, 2 centimeters, like let's say call it. I'm doing the maths in my head here, so I'm going to cheat. I'm going to say that it's 2.5 centimeters or 25 millimeters. Okay, so my image size is 25 millimeters, but I want to turn that into nanometers. So it's going to be 25,000 for micrometers, 25 million for nanometers. And then I divide that by my magnification, which is 2,500. Okay, so cross, 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 cross. Okay, so it is 1,000 nanometers, which of course is 1 micrometer. Okay, and so by doing that, we have answered both questions. All right. Hopefully that's helped you to understand how to do magnification calculations. What I suggest you do is maybe scroll back through this video, going back through some of the points I've made before having a go at some questions on your own. Oh, I'm now struggling to actually stop the video. Classy end. Really, really super classy end, Woody. Come on.